Now we're looking at this pressure worksheet or questions. Right, a student places a pile of coins on a table. The 8 coins, so you've got 1, 2, so 1, 2, 3, 4, all the way up to 8. So you've got 8 coins. The weight of each coin is 0.036 newtons. The area of each coin is 0.0013 meters squared. State the equation linking pressure, force and area. So we're going to write it down. We're going to write it down as words. Pressure equals force divided by area. Yeah, so P equals F over A. You can remember it as force divided by area. Calculate the pressure on the table. Right. So you've got each coin is that 0.036 and the area of each coin, but because they're piled on one another, you only have this area that the coin is resting on. So all the force is resting on this area. And we've got 0.036 newtons. We've got 8 coins. That is our total. Yeah. So it's 2 marks. So we're going to write pressure equals force is 0.036 for 1 coin times 8 coins. And then we're going to divide it by the area. And the area of that the force is acting on is that. So you end up with 220 pascals. Right, okay, so 1 second. Right, let's go back up and write a few things down. So we know pressure, did I just? Okay. Pressure is force divided by area. We can learn it like this. Okay. We know the unit for pressure is pascals, PA, or just change color for that, newtons per meter squared. Why? Because force is measured in newtons and area is measured in meters squared. So it's newtons per meter squared. It's good to know that. Let's keep going. The student spreads out the coins on the table. Like this, spread them out like that. Describe how this affects the total force from the coins on the table. Right. The force is the same, or you can say the force remains unchanged. Why? Because the weight or force does not change. It's the same. It remains because you have the same number of coins. Yeah, you've just spread it out. Now, how will the pressure be affected? Remember we said pressure equals force divided by area. So the force is the same. So the force is 8 times 0.036. But the area is now, the area is 8 times bigger. 0.0013. Because it's spread out over 8 coins. So if you look here, it's no longer acting just here. Now they've spread it out, so you've got, so the pressure on each is less. Okay. So how would we say it? There is less pressure because the same force, the same weight of force is spread over a larger area. That's it. You can, yeah, okay. I'm just looking at what they're saying. Don't say larger surface area, because surface area would be the top and the bottom of the coin. It doesn't, the top of the coin and the side of the coin doesn't affect it. Right, okay, let's move on. Compressed air from a can is used to clean computer keyboards. Use ideas about particles to explain how gas causes a pressure inside of the container. So if you take a cross section, right, you have gas particles, they're moving, that's moving in that direction. It's going to hit the wall here with a force. So it's acting on the inside surface area. So it's force on an area. Now this does that, this does that. Just say, so they're all randomly moving about, hitting. Every time it hits it, it generates a pressure, and then it'll bounce off, hit that, and so on. So we've got to put that into, somehow put that into words. Right, so 3 marker. So we can say the particles, it's better to use the word particles rather than atoms or molecules or whatever. It's just a general term. The particles are constantly moving. Another way of saying that, they have kinetic energy, and they are moving, constantly moving in random directions or motion. They have random motion. Right. When they collide or hit the wall, with the wall, they cause a force on the wall. So now you have a force on an area, yep. And since pressure equals force over area, a pressure is caused, generated. That's it. Done. 3 parts. Moving particles, random directions. When they collide, they generate. Whoa, whoa, whoa. Run. Oh, there you go. Random. They generate a force, and the force is acting on an area, which is the definition of pressure. Pressure is force on an area. Right. The can has a warning sign on it. Pressurized container. Do not expose to temperatures above 50. How would increasing temperature affect the pressure? The particles. Okay, it's a 1 marker, so what was going to... Oh, okay, that explanation is here. Right. It would increase. Explain your answer. Right. The particles have higher kinetic energy, so have a higher speed. the particles hit the wall with a higher speed so remember force is mass times velocity. The mass is the same, the velocities increase, so you're going to get an increase in force. So look, the particles hit the wall with a higher speed, so with a higher or greater force. And also, because they're traveling faster, they hit the wall more often. Right, okay. Right. Right, so this here. So what they're saying is you've got a volume of 400 centimeter cubed and a pressure of 5 atmospheric pressures. Yeah. Now, if you released it, so the volume that's compressed, and this is in the can. When you leave it in the atmosphere, it's going to be 5 times bigger. Oh, that's cheating. That is because the pressure's 5. Right. We want to work out the volume, and we know that the pressure is 1 atmosphere. It's gone from 5 to 1. And we know this formula: initial pressure times initial volume equals final pressure times final volume. They've given us this 400 times 5 equals 1 times V2, because we don't know this yet. So 400 times 5 divided by 1 equals V2. So V2 equals 2000 centimeter cubed. That's it. How easy was that? Right, okay, so we'll call it quits there. But what I want to do is write this formula up here. So it's good to know that. So the initial pressure times the initial volume equals the final pressure times the final volume. So basically you've got 4 variables. If you know 3 of them, you can work out the 4th one. P1V1 equals P2V2. Right, okay, call it quits there.